So I'm not sure if you guys had already left or whatnot, but there was one boy in here. Who was it? Oh, he's not even. Oh, it was Akshay. Akshay wanted some more of the like conceptual stuff and the definitions. So what I did was I added, and you guys can't see any of this right now, so let me share it with you. What I did was I added like the CP type of thing, which goes more conceptually and less into the math, just so you could sit here and try some of these things. It is a comprehensive review. If none of this, if you don't care about any of this, by all means, this is not something that's going to be turned in anyway. The problems here are kind of more general. They're like, okay, if we double this, what happens to this type of thing? But there are problems similar on to the test on this. Don't think that this is just like, well, it's CP, it's, you know, it's minimal or whatnot. Like, I would say that to make it more questiony, like so that I can give fewer points per question, I added more of these like, you know, how do gas particles move, stuff like that. Think about, currently I have 69 points made of the test, and I think about 30 of those 69 that are made right now. Oh my God, Dawson. 30 of those points, like basically 10 questions, are these conceptual things. The rest of it is going to be, the other 31 of that is going to be math, basically. So that means it's going to be about 2/3 math and 1/3 of this conceptual stuff. Another reason for that is I'm calculating probably 3 minutes for most of the problems to be figured out mathematically. In these, you know, these other questions, this 1/3, you should be able to sit there and look at it and answer it within 45 seconds. Does that make sense? I believe that the answers are up. Boom. Yes, I will. Mm-hmm. So what I did was this right here is the older view, but I added problems that I thought were more closer to the mixture of both, not making the test more heavily math. So this more comprehensive review, it might be the better of the two. The one that I had here, that's like the end of the, what do you call it? The end of the new, yeah, like the second half thing, yeah. If you go all the way to here, where the second part of the gas unit was, I put that together before I left for break. And I feel like in my mind, if you stop after this review, or if you don't even go, if you just stop right here and you go to the other review, I think you'll be better off. Because these problems right here, the additional problems, I don't feel like they will help you if you've done the other stuff. These problems are much more heavily on math, but if this is something that you require help on, then that's you. I mean, this has you go through basically all of these different things for this one equation. Totally up to you on that. I'm not asking you to do that at all. If you do it, it does have the answers on the last page of it. But I'm not going to work through every one of those problems. I will only work through those problems if you come in tomorrow and you ask me questions about them. I will work through all of these problems on this, whatever we're calling this thing. The new and improved, the additional problems added to the review. I will work through everything on here and have an answer sheet up by the end of the day. Does that make sense? Cool. So if you have any questions from any of these sheets or whatever, by all means, I'm going to print one of these out just because I don't think I have yet. By all means, ask away. I can write the question down and we can answer it. If you are like, cool, you're going to put the answers up. I'm still finishing lunch or whatever. That's okay. But before you do leave, please keep in mind that the test is over gases is tomorrow. And that's a very fluid. Fluid's like the new word that they use always at Mr. Brannigan says fluid like 25 times a day. But it's very fluid. By all means, you can skip lunch. You can come in and you can take that test, you know, and you get that whole 65 minutes. You can wait till after school, take it, get that 65 minutes. You guys, I don't want you skipping lunch really. I mean, when they say skip lunch, they're at home eating. Like you wouldn't have any time other to eat. You guys are more than welcome to go to lunch, come in and ask me questions, and basically I'll give you until Saturday to finish, if that's cool. Hopefully, I mean, yeah, we do have to make concessions. You don't want to be forced to take it in here, I'm sure, for whatever reason that is, right? But yeah, cool. So that's basically what we're doing. Any questions on that? All right, let's see. I've got a hydrogen balloon in the back of the room. So I'm going to try to do the thing where we switch, and I'm going to talk to you through the other computer. I just got to go through the steps that I use to do that.
Wait, Mr. Jackson, I have a question.
Yeah.
On some of the problems, I was getting like 0.1 and 0.01 off. Is that okay? Or are you going to count on?
That's going to be fine. What it is they're probably not using the 0.15, the 273.1.
Oh, yeah, okay.
That's probably what
Okay.
it is. Yep. Or they're only,
So
yeah, I mean,
is the test
that's less
going
than,
to be multiple choice questions?
no. Some will be multiple choice. Not, what's that sad face for, Dawson?
I think it would be easier if it was all multiple choice, but
Oh, no way, right? If it's all multiple choice, then I put the trickery on it. Right? We make it tricky if it's all multiple choice. Any other questions before I get the other computer set up?
So it'll be like more accurate than the worksheets with like the point ones. You know how sometimes the worksheets are messed up? Will the test not be like that?
It won't be like that. You'll be fine.
Okay.
And if you think that you're being messed up or whatever, then we'll get into a Zoom and I can show you your answers. Cool. All right. So how about this? Because I want to be able to write down stuff. Can you guys envision a white balloon in the back of the room? Yep. It's just a white balloon. You guys can see it, right? Let's see if I can zoom. I don't know if I can zoom this in, but it's right back there. If you're on the class picture, it's just sitting back there. Now, that is 8.2 liters of hydrogen gas. So let's do a little bit of math on this. Are you guys ready to math some stuff up? We're going to take you through kind of a little bit of a thought process. That's where you are. So it's 8.2 liters. Where's my visualizer? I hope your other teachers are more amazing with all this technology stuff than me. So I always feel like, where's this thing at? And then, you know, there's like just so much to do. How's that look? Looks good. All right. So 8.2 liters. 8.2 liters of hydrogen gas. Right? Can we figure out the temperature of that hydrogen gas? Yeah, what would it be? The temperature of what? Anybody? Yep. Anybody can talk. If that balloon is in the room, What's the temperature of the gas in there? Hudson, tell him.
Room temperature.
Yeah, right? So we got to just find the temperature of the room. So it's easy. We got a thermometer. You want to try to read it? Oh, you could get up. Yeah, yep. So we got somebody getting the temperature of the room. It's the blue one. 20, is it between 21 and 22? Yep. How far is it? Is it closer to 22 or 21? So 21 point, is it more than halfway, right? It's basically on 22. So if it's not on 22, but it's basically on 22, 21.9, does that work? All right, 21.9 or 21.8? All right, cool. So this is our volume. This is our temperature, 21.9 degrees Celsius. If you get a chance, maybe when you guys come in next week or you guys after this, you might want to look at an actual barometer. They're a little bit more difficult to read. Basically, you've got to get the temperature gauge on there and it moves down. 773.0. So the barometric pressure reading in the room is 773.0 millimeters of mercury. Somebody want to tell me why that's not exactly the pressure in the balloon, but we're going to pretend it is? The balloon's not getting bigger or lower, but why is the pressure of the gas inside the balloon not 773.0?
Is it because like it's closed, the balloon is closed?
Yeah, and if you were to open the balloon, what would happen immediately to the gas inside of there?
It would release into the
It
atmosphere.
would release, right? So the pressure inside the balloon, the gas pressure inside the balloon is actually a little higher than this 773.0. That's because it also has to resist the elasticity of the balloon, right? So the balloon actually has a force of its molecules trying to pull on each other. So the gas inside of there has to be a little bit higher. Now, with the gas inside of there and the balloon holding it in, that pressure is equal to the pressure outside, in a sense. All right. So we've got all this. We have P, V, and T. How could we find the moles of the balloon?
Can we just do PV equals nRT?
Yep. PV equals nRT. We rearrange this to solve for PV over RT equals N. What are we going to use for our R constant? Okay.
62.4.
62.4. Comfortable with that R
Yeah.
constant? That way we don't have to change this, right? I'm okay with it. 773 times 8.2 divided by 62.4 divided by, oh, nobody changed my temperature. 21.9 plus 273.15.
The answer is 294.9.
Our big loser today is going to be this volume. So I'm just going to leave it as 294.9. 773 times 8.2 divided by 294.9 divided by 62.4.
It's about 0.3444.
So we got 0.3445 moles. Now, I want you to calculate when that hydrogen gas ignites with oxygen. I want you to calculate how many moles of water will be formed. So how do we do that?
Write a balanced equation.
Yep. H2, and we're adding what to it? O2. That's going to make H2O. How do we balance it?
You need to put 2 in front of 2H2O, and then you need 2 in front of H2 on the left,
Good.
and then that's it.
So we're going to make 0.3445 moles of water. And this is one of the best ways you could make water. It's actually the reaction that makes water. There are some other reactions where you get water, but this one's probably the coolest. So do you guys want to take a vote of who in here should make the water? Or do you guys want to pick? Make the water. Who's going to ignite that balloon? Anybody brave enough? Olivia's brave enough? A little bit scary. No? Am I going to have to do it? I'm going to switch you guys over to the other camera real quick. Hopefully we'll have whoever. All right, let's see if this will work. You're going to want to move forward, probably. Can you guys hear me?
Yeah.
Yeah. All right, is that how you imagine that white balloon? At least nobody's worn these today or anything, but up there in the bucket, there's some earmuffs you're gonna need. Yeah. Yeah, blue bucket and the red. You grab the other card for me. Okay. Nobody's worn these either. Don't know if these will fit over your glasses now. All right. You guys are going to want to cover your ears as well. That's a super fall. So I'm sure that you don't want to light this with your hand right next to it. So I'm going to give you a 1 meter advantage. But can you guys see the balloon okay? Yeah. You guys, I can't see your thumbs up. Somebody
Yeah.
Right here's the balloon. Can you see that? Dawson?
Yeah.
I'm going to give you this advantage, but you want to be like this when you do it, so you not only have that advantage, you want to put it right underneath. I guess that's the only thing I'm worried about. I'm going to blame you. All right. So let me get, I think I've got a lighter up here. That's going to be better matches. All right. I got to win this battle. All right, I'm nervous for you a little bit. You got a strong heart. You don't have no issues. You don't have like Spider-Man. All right, you guys.
Hudson, you're not looking at the balloon.
There may be a wave that takes you guys offline. I'm not sure. We'll have to see. I'm gonna turn this off. Ready? Wait till I get away from it. Yeah, just like you were going to set it on fire. Like, don't hit the string, though. Like, to the side of it. Hold up. All right. I don't want to block anybody. thing you wore the earmuffs, right?
I felt it in my
So we just made, what was it, 0.0344 moles of water?
Yeah.
That's amazing. Oh yeah, that'll work. I know my heart jumped. How about yours? Yeah, a little bit. That's all I've got for you guys today. If you have any questions, by all means, come back on, and I'll be sure to answer them for you.
Thank you.
Have a great day. Bye. Yeah, that's a big one. One time, I thought that the glass, like, that's why I moved it over a little bit. I thought the glass was going to break. That could have been bad. So you guys are more than welcome. As I said, I'm finishing up the test as we speak, but if you have questions or anything, you're more than welcome to ask them. Is it something where I can, like, you can give me a number?
Yeah.
Yep, let's do it.
9 and 10, they're the same problems, just like different numbers on page 9.
9 and 10. A gas of unknown composition?
Yes.
Yeah, all right.
At this time, all students currently in lunch are dismissed. Again, all students currently in lunch are dismissed.
How is lunch? Like, I mean, not the people, but the food quality. Is it better or worse?
I didn't get school.
I think it's a little worse. Yeah, it's worse, and there's less options. Yeah.
There are more options or less? Less?
There's like
Way less.
2 options. Crust cut on, crust cut off.
little burgers in the back, like the summer down.
That's, yeah. I know that the nutrition lady at the lunchroom, she works really hard on that. She really takes her job seriously on that. I mean, but it may not seem like it to you, but you know, it's like that is a definite job. Like, there's nutritionists for jail cells and prisons and stuff like that. It's kind of crazy, like, the people go to school and do that stuff. It's crazy. All right. A gas of unknown composition diffuses at a rate of 10.0 milliliters per second. Hydrogen diffuses at a rate of 30 milliliters per second. Calculate the molecular weight of the unknown gas. So it's always the same thing. Basically, we have this set up right here. What's the easiest way to solve the molecular weight side? If I put it on top or bottom?
Bigger number.
Bigger number on the bottom? Well, I don't know if it's bigger or not, but it's probably bigger than hydrogen. So we'll put it on top. If I have my X at the top, then I don't have to do any craziness. All I've got to do is square this and then multiply by this, right? Yeah, so if I put my X on top, always, if you have the ability. So,
At this time, based on schedules, all other students may be dismissed. Again,
2.02.
students reporting to the cafeteria, please remember to pick up a sanitizing wipe and clean your eating area first. Thank you.
And hydrogen goes at 30.0 milliliters per second. So remember, we always put them catty corner, right? If this is gas 1, this is gas 1. This is gas 2, goes at 10 milliliters per second. It doesn't matter, that's going to cancel it anyway. And there's our X. So 30 divided by 10.
That would be 3.
So that's 3. We square 3 because we square both sides. And 3 squared is 9. 9 multiplied by 2.02, because we multiply both sides by 2.02, is 18.8. So it's all on the setup of that, and you always want to make the X your easy one that you can get. Yeah.
But you keep me first. Okay, so number 8 or number 4 on page 8.
Number 4 on page 8.
Yes. This is like the
This is the review one. How many liters of carbon dioxide gas are produced when 24.7 grams of copper carbonate are decomposed? So a metallic carbonate. Do you remember what the decomposition of a metallic carbonate yields?
CO2 and then metal.
CO2 and metallic oxide. So I believe it's a 1-to-1 thing. So that's not a big deal. 24.7 grams. Every so many grams of this is going to be 1 mole. Every 1 mole of this is going to be 1 mole. And it's not at STP, so we're going to wait. We're just going to find the number of moles then we're going to put it through PV equals nRT. $63.55 plus 12.01 plus 16 times 3.
The answer is 123.56.
There's our molar mass. 24.7 divided by 123.56.
The answer is about 0.1999.
So there's our number of moles. We have PV equals nRT, so V equals nRT over P. Right? Moles, we have 500 torr. 500 divided by 760. 500 divided by 760.
It's about 0.6578.
So that's how many atmospheres that is. 25 plus 273.15 is 297. 273, 298.15. So 0.1999 times 298.15 times 0.0821 divided by 0.6579.
It's about 7.4375.
7.4375, which rounds to 7.44.
I have a question. How did you get the 123.56 in?
It's copper, carbon, and oxygen on the periodic table. There's 3 oxygens, so that's 16 times 3, plus the 12.01, plus whatever copper is.
And did you divide 500 torr by 760
To get the atmospheres, yeah. You divide it by the 760. Remember, torr and millimeters of mercury are the same thing.
Is there like any real difference, or are they just?
There's no difference. One is the actual millimeters of mercury, which you're measuring. That's what Torricelli did. But since he created the first barometer, there was a group of scientists that basically said, hey, let's name this after Torricelli. We'll name it the torrs. Just like Anders Celsius, right? You might hear the word centigrade. Some people would say instead of 10 degrees Celsius, they would say 10 degrees centigrade. It's the same thing. Scientists were sitting there, using centigrade, and then they're like, hey, let's attribute somebody something Celsius.
Did you look the number 11?
I don't think there's like a guy called Bobby Inch or something though, right? But, inches and foot, but yeah, but with a lot of these, these are named after people's names. Which one?
11. Page
11 on page 9. A mixture of 6 grams of oxygen gas and 20 grams of nitrogen gas and 14 grams of argon gas is stored at STP. The total pressure in the container is 3 atmospheres. Find the partial pressure of each gas. So we've got to change all of these to moles. And then we'll know the total number of moles and the pressure. 6 divided by 32.
That would be 0.1875.
20 divided by 28.02.
That would be about 0.7137.
14 divided by 39.95.
It's about 0.3504.
So that's how many moles of each of those are. 0.3504 plus 0.7138 plus 0.1875.
That would be 1.2517.
So 1.2517 is the total number of moles. So that's in total. We want the partial pressure. We want pressure. So again, I asked you what should we put on top. We should put pressure X on top, right? So this will be the X of O2. The total pressure is 3 atmospheres. And this time we actually keep it. We put the total on the bottom, 1.2517, because there is no square root on this. It's just a ratio. This to this is this to this. So the total number of moles has a total pressure of 3.00 atmospheres. And for oxygen, 0.1875 moles is going to have whatever that is. 0.1875 divided by 1.2517 times 3.
That would be about 0.4493.
Actually, it's 449 atmospheres. That's probably what's I can't remember his name now, but he was saying I'm always 0.01 off or whatever.
So what do you multiply the grams by?
Periodic table again.
Okay.
But it's diatomic, right?
Diatomic.
Yep. So to go from, except for argon.
And then you just repeat that process for every gun. So
Yep. So then instead of O2, we would put into, and we would put this 0.7138 over here.